Good morning, good afternoon, good evening around the world. Thanks for watching this video. My name is Taejun Kim, and this work was done with my great collaborators Youngbo, Aram, Shim, and Geehyuk. We have proposed Heterogeneous stroke, a design concept that uses unique vibration cues to help clearly recognize the complex tactile patterns on the small wrist area. Let me share you our work and some interesting findings today. When we can't fully occupy our visual attention to the screen, tactile display is a viable supporting option to deliver information, since the watch always contacts the skin of the user. And today's typical smartwatches in the market vibrates the entire frame of the device and deliver simple information such as incoming calls or messages. And beyond of that, researchers have been seeking ways to expand the capacity for more helpful information. For example, the sender of the message, the distance left, the direction to turn. There are a lot more possibilities we can achieve. By using multiple tactors, researchers proposed spatiotemporal tactile patterns to deliver high-level information such as alphabets or numbers or directions. However, because of the limited skin area of the wrist, confusion between tactors easily occurs as in shown example. And this is the main reason of low recognition rates of tactile patterns when using multiple tactors on small wrist area. And furthermore, the recognition rates reported in previous studies have mostly been measured with a specific posture. So if we consider that we take diverse arm postures in real life, the practical recognition rates can be further decreased. So herein, as a solution to improve the pattern recognition rates, we present heterogeneous stroke, which is a design concept that utilizes unique vibration cues for each tactor. As the stimulus of each tactor becomes more distinguishable, the overall pattern recognition rates can be improved. And we designed 4 unique vibrations by combining 2 levels of frequency and roughness of vibration. And this is our implementation of heterogeneous stroke concept. Okay, so from this slide, I will briefly explain the experimental structure of this paper. So first, we investigate whether the arm posture affects the pattern recognition rates with controlled experiment. And then move on to our main topic. We investigate how much heterogeneous stroke concept can improve the recognition accuracy. In user study 1, we used primitive pattern set which forms elements of any spatiotemporal tactile patterns. And in the following user study 2, we used edge-right pattern set which can deliver 26 alphabets and 10 digits. In the preliminary study, we found that the arm posture can significantly affect the tactile pattern recognition rate. This implies that the different arm postures need to be considered when designing and evaluating the tactile pattern set. And based on this finding, we designed user study 1 and 2 to consider different arm postures when verifying the heterogeneous stroke concept. In user study 1, the heterogeneous stroke method shows significantly higher accuracy than that of baseline. And in the following user study 2, we test the case of delivering alphanumeric characters. We showed that the heterogeneous stroke method showed significantly higher accuracy for every condition. And in average, we achieved high accuracy of 94 and 92% for 26 alphabets and 10 digits. And this is the main contribution of our work. We proposed a design concept of heterogeneous stroke, and we empirically showed the effect of a heterogeneous stroke concept. Okay, so this is the end of my presentation, and thank you for your attention, and I'll be glad to take your questions.